Okay, we're going to pick up today with the same lesson we did yesterday. We're just going to talk about parent functions, more difficult transformations today. Oh, excuse me, smoker's cough. Here we go. Okay. So I've got y equals 1 over x. That's the parent function. Do you remember what 1 over x looks like as a parent function? A lot of people did in the previous hours. Oh, wow, you got it. Doyle's got it. He says vertical asymptote, horizontal asymptote. And then we have the graph in the upper and lower portions of it. Okay? So what we want to do now is we want to perform the transformation. You do see the +2. So you're like, what am I going to do with that? Well, I will say that it's slightly different than this one down here. Either the +2 or the +3 is on the outside or inside. You think that this is on the outside or inside now that you look at that one down there. It's on the inside, yeah. And so what would you plug in to make 0? -2. So it's going to move 2 units to the right. And so that will affect the vertical asymptote. So this is the new vertical asymptote. Shifting the horizontal asymptote to the right doesn't change it, or left doesn't change it at all. So this is my new graph in green. What we would like to also do is state the domain and the range for this. What is the domain of that function? Remember, domain, we drag a vertical line across. What's the only spot that you don't have an x value? 0 for the original one, but for the green one, -2. So x cannot be -2. And for the range, we would drag a horizontal line. And as you drag that horizontal line, what's the only spot that the graph does not have an output? Yeah, very good. The graph does not have an output at 0, so y cannot be 0. Good work. The next one, y equals x minus 3 to the 1/3 power, so that would be cubed root. You look at it, you're like, Mr. Gantz, we haven't talked about that yet. Well, if you consider it as a cubed root of x minus 3, then you would say, oh yeah, we can. So some of these you're going to have to rewrite in a way to understand what is the graph actually saying. Do you remember from yesterday what the cubed root function looked like? Kind of does that thing, okay? So there we have it. What's the transformation? 3 to the right. Domain, all reals. Range, all reals. What's different about the next one compared to the first one? Squared. What's the squared going to do? Square something is going to make positive, right? So you're not going to have anything in the lower quadrant. It's going to be up in the upper quadrant. So therefore, our parent function looks very similar. We have a graph up here, but the other graph stays above the x-axis, not below. So that's what happens when you square it. But we have some transformations that are happening now. What is the -3 going to do? 3 to the right. And then forget about the 2. The 2 is simply a multiplier. It just stretches the graph, and you're not going to really show that. But the negative up here, that's on the outside. What does the negative on the outside do? A vertical flip. Yeah, so it's going to flip everything down. So I'm going to move this to the right 3 units. And then I'm going to flip everything over that axis. So the domain is going to be x not equal to what? 3. And the range is going to be y, well, let's see here. This would be from -infinity to 0, but not including 0, right? What's the parent function look like for a square root? You remember this. Square root function? 4 minus x. What's going to happen with the 4 minus x? What do you plug in to make 0? 4. So it's going to move 4 units to the right. Plus 1. 1 unit up. But I have a negative in front of the x. What's the negative in front of the x do? Is it negative on the inside or outside? Inside, so it affects it horizontally. So it's going to flip horizontally the other way. Next one, you're like, Mr. Gens, we haven't talked about that. Sometimes you need to rewrite it. How about negative x minus 2 to the 5th plus 4? Now maybe it looks a little bit more manageable. Do you remember what a 5th powered function looks like? Like a cubed. Just a little bit more stretched. So that's my parent function. What do I do with that? 2 to the right. Up 4. Upside down. 2 to the right. Up 4. Upside down. Away we go. Domain, all real numbers. Range, all real numbers. 1 over x plus 3. You've already seen this parent function. You remember the reciprocal function? They're going to be in opposite quadrants, one in the top, one in the bottom. What's the transformation? What happens? 3 units up. So that will move the horizontal asymptote up to 3. The vertical asymptote doesn't move. Anybody domain? X can't be what? 0. Y can't be 3. X can't be 0, Y can't be 3. How about this guy right here? Is that going to look more like the first one or the third one? Which one's it going to look more like? What do you think? Why do you say third? Because it's got the exponent. Exactly. Okay. But is the exponent odd or even? Odd. And we see that this also has an odd exponent. So if it's got an odd exponent, it's going to look more like this one. Even exponent, it'll be above the x-axis. So we see that odd exponent. So that means that its parent function looks just like the first one, basically. What are my transformations? 3 to the right. What else? Yep, a flip, upside down. So instead of being the lower quadrant first, I go to the upper one. And instead of the upper one, it drops to the lower one. Dane, you good? The negative on the outside, because it's on the outside, creates the vertical flip. Got it now? Domain. X can't be what? 3. range, y can't be 0. Now we've got a root function, a fourth root function. Is that going to look more like a square root or a cube root? Square root. 2x plus 6, that's all on the inside, so it's going to affect it horizontally. What would you plug in to make 0? Negative 3. So it's going to shift it 3 units to the left. Domain, negative 3 to infinity. Range, 0 to infinity. Do 2 more. Cubed root function. Remember? What's my transformation? Vertical flip and 2 to the left. Domain all reals. Range all reals. So we do one more. We do this one right here. All of a sudden, you see one look like this. You're freaking out. You're like, hey, Mr. Gans, come on. We haven't talked about anything like that. Yeah, actually, we have. This is negative x to the 2/3 plus 4. Ooh, do you remember what something to the 2/3 power looked like? Third function. When you square something, it will become positive. And when you cube root it, it will stay positive, right? That's why it's always above. Because you square it, it's positive. You cube root it, it's positive. And you can plug in anything. Because you're not taking the square root, you're taking the cube root. So that's why you get that. What's the transformation that happens? Yep, up 4 and vertical flip. So I'm going to draw some attention to Ashley real quick, because the other day we had this on the board. We had y is equal to, and we had 2 times the cubed root of 3 minus x plus 1. And the question was, boy, how would we know how that's graphed right away? And the answer is, or was that Josie? Okay, so it's Josie. Look at how quickly we could sketch that. You know what the cubed root looks like, right? Well, it's just going to be right 3, up 1, and a horizontal flip. Right 3, up 1, horizontal flip. And if you remember, that's what we sketched with our calculator. The graphs could come that quick. There you go. Get to work. Later, YouTube, especially Rachel. We hope you're doing okay. And Marty. I hope it's cloudy in London. Cully misses you. Sad day.